it looks like it's 12:30. Um, so I want to welcome all of you to PDH Hour with Glenn. I'm Glenn Tepfer, your host, president of CQA Solutions. And today I'd like to dive into the topic wedge welding data recorders, the unspoken truth. Um, First thing here I want to do is give you a reminder that prior webinars can be found on the CQA Solutions website. So you can go to www.cqasolutions.com, go across the top to training and education, click on webinars and then webinar replays. Um, One thing is we won't be able to issue PDH hours. We only issue those for the live class in this webinar. And then also, if you save your questions, you can type them in. I'm going to use the question and answer feature I used last time. I still need to get back with people from questions from last time, so I apologize for that. We've been working on trying to get some answers, and I actually believe a few of them will be covered in here, but I want to follow up and make sure I do that. So as an outline, what I want to get at is the first thing, just discuss the need for the discussion. Why do we need to talk about the data recording? I'll give you some background then, parameters for thermal welding. Where do we find current guidance on the data recorders? Concerns that I feel you should need to be aware of regarding data recorders that you're probably not going to hear from many other sources. Then after all that, can this data be successfully used, given the concerns mentioned? I do think there are uses for it, and then we'll get into that. And then I'll give you an overview of my next webinar, and we'll address any questions and answers you have as time permits. So thank you again for attending. The need for discussion. Basically, my quest to get answers on this started, is it? My quest started here to get answers back in 2022 after I read this article in Geosynthetics magazine. And the authors made some claims, and I don't necessarily agree with those claims, and we'll get into why, but that really started me on a quest to learn more about data recorders. I've been involved in some committees associated with them. A lot of people pressuring me on those committees that this is a great technology. It needs to be in everybody's hands, but I believe we need to take a more cautious approach, and I hope I can share and have you understand why. I think it's a good technology, but I am apprehensive about it. Just some background on this article that I mentioned. They have two different sites where they did it, and as we go through this webinar, anytime I refer to the article, it's really referring to that specific article in Geosynthetics magazine. They had site one that they installed in December of 2020. The project size was 0.2 acres, 60 mil HDPE, and they used a Leicester GeoStar G7 data acquisition welder. Site two was done in March of 2022, 20 acres, project size 40 mil HDPE, and they used a Demtech VM20A with ProData as their data acquisition device. So that's some side information. Another reason why I feel we need to do this quotation that I found in a recent patent that was granted. If you read the quote, they have a process where their software, they can plug in different data and it'll generate an as-built is basically what it seemed to boil down to. I'm not sure about any of the other data that we're going to discuss in here, but on the center of this sentence, it says, their algorithm is going to not allow for any geomembrane installation to be out of project specifications, all but eliminating the need for third-party inspection. And I just think that's an absurd claim, and I can't believe that the people that put that together actually made this claim. And I'll show you why here. So yeah, I think we need to be aware of claims like that, claims like in the geosynthetics article. We need to uh, learn what to take away from them. Um, the slides that I put together, a few slides here, are sample project geomembrane specification summaries that we always do before our geosynthetics projects. And it's going to show you some things, that an algorithm just simply can't solve. There's different, we got to make sure we have the right equipment on site, and right materials on site. The algorithm can't really tell you that um, unless it's programmed in there. People put in the data. Same thing with inventory, storage requirements. Is the material being stored properly? Is it being handled properly? Subgrade requirements, are the rock sizes being met? Anchor trench dimensions. Is the anchor trench located in the right place? Deployment, run out from the toe of the slope requirements, things like that. They can be possibly done through an algorithm, but there's a lot of things that can't. Trial welds, things like rub sheets being used, if they need to be pulled out, where they pulled out, things like that. There's just a lot of things that third party does that um, can't be seen or done by an algorithm or a data recorder. And, so on and so on throughout the installation process. You can get into, oh, have all the damages been repaired? If they're not been marked, then how do you know that everything is sound? You can do an electrical leak location, but that doesn't really matter at the end of the day. That's only telling you continuity. It's not telling you the integrity. So now that I'm done with that little side rant on the claim and the patent, I want to get more back on track, focusing specifically on the data recorders and the thermal welding. In my last webinar, we went over some of the parameters that are required for thermal welding in much greater detail. And so if anybody didn't get that one, again, you can find it on the website. But just an overview here. Mehdi Weiser from Leicester, in discussions several years ago, came up with this magic triangle where it really captures the three components needed for a sound weld: your heat, speed, and pressure. And your different materials are going to fall within, different areas of that triangle. And I argue that different manufacturers are going to fall within different places, even of HDPE, LLDPE, whatever they may be. I think there's going to be different sweet spots for the different manufacturers. One thing that often is not mentioned is, power supply and having a consistent uniform power supply. That's critical if you want to have a consistent quality weld. And this slide here indicates some generator requirements from the Demtech handbook, their operator manual, and what the requirement has to meet. But we've been in the field where we see, a generator being used on the left, that's probably going to meet the requirements. But the one on the right is a handheld generator. That's not going to meet the requirements. And it's not going to offer any consistent voltage at all, especially with a long power run. And then that gets into, extension cord lengths matter. I've taught this, I know, for years, that we need to be looking at the number of connections. Demtech's manual here has a maximum length. It has 10 gauge, 12 gauge wire. What if you use a different gauge? It's not listed there. So people need to be checking that out. And I think voltage can be um, attached and recorded. So I'll get into the requirements for data recorders next here. Where does the information come from for the requirements? The United States and other countries we're looking at. The United States, we had GRI GM32, and it came out in 2019. And then recently we had ASTM D8468. I'll quickly run back a couple slides here. Really, I'll start at the background, the magic triangle that Eddie had here. So those of you that didn't make the last webinar can see this real quick, but we have the heat, speed, and pressure. And then you're going to have that for different materials. They're going to fall within different locations, obviously. And like I was saying, I think different manufacturers of different HDPE, same thickness and everything, are still going to fall in different spots due to their proprietary formulations. Generator power requirements is where I was at, just showing you the difference. Um, and then the extension cords here from Demtech. Um, you can see here their different requirements, and that's to get the best and most consistent power possible at the machine. So requirements for data loggers, as I mentioned, I looked in the United States and then tried to find some data in other countries. United States, I was just starting to talk to you about GRI GM32, and that was done in 2019. More recently, ASTM-D 8468 came out in 2023. So, and looking at these documents, both really have some concerns and shortcomings. And the GRI GM32, I wrote a couple blogs that can be found on uncontained.co about these shortcomings. One of the things that I felt was that it raises more questions than answers, and most of these questions remain unanswered today, as you'll see as we go through this. There were a lot of ambiguities in GRI GM32. They have a seaming window or seaming bubble. That's left up to the installer, and it's based on passing trial seams and passing non-destructive tests. Then there were things about, appropriate recorded values are undefined, and then who determines these, when are they evaluated? Operators are still responsible for adjustments, and there's no formulatic guidance provided. Section 4, the summary of practice, they say right in there that by observation of the output, the operator can make periodic and timely adjustments. In doing so, it is expected that the seaming process stays within the material-specific and site-specific acceptable seaming bubble or seaming window. Well, that is expected is a large unknown to me because, as I'll show you, we don't really know where we're at in our trial welds when we start them. And then, what to do with the data, who reviews it. Section 6A said that there's a procedure with conventional welding devices. So they're talking about the welding devices that don't have the data recorders. They say, quote, the issue with such conventional welding devices is that an operator never precisely knows where the outputs are within the window or bubble, unquote. Well, my question is, how has this changed with the use of data recorders? We still really don't know where we're at in the bubble. And I'll show you that here in a minute. There's requirements for accuracy and tolerance of welding machine are missing. Section 6B was one of them that's dealt with a procedure with data acquisition welding devices. And they have note 10 under that that says critical in the proper functioning of such welding devices is to have initial and ongoing machine calibration practices. The device manufacturer's instructions must be rigorously followed. They're talking both machines there is my take on it, but either or. How many times have you ever seen a calibration certificate for a welding machine? I mean, we never get them. Nobody's ever provided it. Everybody just says that it's been calibrated by the manufacturer, but even so, when you're on a site, you see installers, they'll tear the equipment apart, they'll put it back together. What does that do to any type of calibration? And should it be a big deal, But I think when you're talking the data recorders and you're trying to make decisions based on it, it becomes more of a big deal at that point. And then, we talked about verification, the calibration, and same thing, the accuracy and tolerance of the data recorder. Nothing was mentioned. There were limitations on GRI, GM32. They reference a GRI document that only members can get. They assume that the data is being made quickly and timely, available to third parties, and being reviewed timely, which isn't always the case. But in the article, I know they did have a requirement that the data would be turned around at the end of the night or the following day, but I think that's even too late to make some of the decisions that are being made. Um, it assumes that the recorded distance location can be accurately repeated, and then lacks guidance for the closed loop technology, which a closed loop technology I explained a little bit in the last webinar, but the closed loop has a circuit that monitors the electrical input and keeps the motor and heating element automatically adjusted so they remain the same as long as they're getting uniform electrical current, which helps ensure more uniform welding parameters. But yet, GRI GM32 doesn't deal with machines that have this capability, and it seems like a great capability. And then the field-oriented scope, it really targets CQC and CQA people, but it really doesn't tell engineers anything or any of the other parties that might need to look at the data. Then it's unclear if the practice is supposed to be part of the permitted plan, specs, or bidding packages. Those assumptions are made sometimes. And it really falls short of recommending normal CQA practices. Some additional concerns, I believe, and then without GRI GM32, that the welding guidance really should come from the geomembrane manufacturer, not just installers. It should come from somebody that actually knows what's happening to the material when it gets heated to a certain amount. Because we are having a lot of overheating and thinning that's becoming a more and more prominent issue in the industry because installers have learned that they can overheat the material, which compromises the long-term performance, but they pass their peel and shear test. Other key issues with this, technicians should inspect, it's not recommended, but they need to inspect the machines, the setup of the machines, all the data being acquired. And then there is no mechanism for the QA to track the adjustments and actually assess their quality. We can see that they changed something, but what do you do there? There's no guidance on what to do. Um, then there's gaps too, because there is no training. There's no training for the technician that's doing the welding and what changes they can make. No clarity for reviewing the data and what is a problem. So then I moved on to ASTM D8468, and I look at a few sections of this here. Section 4 is the significance and use, and 4.1 has recording of the welding parameters at predetermined intervals. Well, who determines these intervals? The machines can be set up to record at different intervals. I don't remember what the minimums are. My understanding is that they're continuously monitoring, but they only record. But 4.2 is facilitate detection of anomalies, which is great, except that we don't really know what is an anomaly, and how bad is that anomaly. Is it something that warrants looking at or not? Section 4.3, this practice does not cover the precision of the measurement, that is, the accuracy of the recorded values of temperature, speed, pressure, or position on site, which that's a big one. There needs to be some guidance on that, but I think maybe that comes from the manufacturer or something like that, but there's definitely room for improvement in that regard. And then 4.4, parameters such as the frequency at which the data are recorded may be adjusted by the user. I touched on that one earlier, but the user can really set it. They could record every 100 feet, and you're not going to have any data points to go off of. It's whatever the capabilities that they can set. So it really needs to be looked at and verified by the end user. ASTM, some more, Section 5 here, the apparatus general requirements. Section 5.1.4 says calibration requirements should be followed per the manufacturer's recommendations and documentation supplied accordingly. That's for the data recorder. And then 5.1.7 talks about sufficient storage because these machines can end up getting full of their data, and once they get full, they're just going to overwrite the data. So if you're on remote sites or something like that where you don't have internet connectivity, it needs to be dealt with ahead of time before they start recording and find out, hey, we lost our records, we overwrote our records. Section 7, the procedure, 7.2 has, quote, verify that the device manufacturer or distributor has confirmed the accuracy of the welding parameter sensors on the device. Excuse me. To me, that's a big one there. We'd like to have the accuracy verified, but how is that done? I've never seen anything done on that. And it's another vague area out there. And then how often do you need to verify it as well? Because it can change if the machine gets dropped, something like that. Does it change? It's all kind of a gray area out there. Then 7.3, we talked about the data. 7.4, again, selecting the data recording interval as required. So that interval can be adjusted. And if someone's using it, they need to make sure it's set and that it's, being recorded at the set and desired intervals. Section 8, the report, one of the biggest shortcomings I've seen here is nowhere is the seam number required. There's a difference in the manufacturing that the article touches on, and I know from talking to the manufacturers as well, but one of the machines, the data recorders, records every seam sequential as a numeric number, 1, 2, 3, 4, 100, 101, whatever. So 1, 2, and 3 might be trial welds. And then 4, 5, and 6 could be seams, but the end user has to go back in and plug in the actual seams, which leaves a lot of room for error to be, put in there, especially if you have data that may be the same seam, but different segments of it. And then, I think, as I said, voltage should be included. It's optional in this report in ASTM D8468, but if you look at the German guidance document, DVS 2225-6, they say by indicating output, heating capacity and machine drive, the machine load can be monitored on the basis of set reference values. In the event of irregularities in the main supply or damage to the components, it's easily recognizable from the change in power consumption. So if it's important enough to put in the DVS as a required, why isn't it important enough in the United States? And then, I'll go into technical code DVS 2225-5. It's joining of the lining membranes made of polymer materials, site testing requirements for welding machines and devices in February 2019. It's the most recent one from the German Welding Society. And there's a couple things here that they talk about. For certain applications, a data acquisition system is also required. So then they give the purpose, and the purpose is to verify that the selected welding parameters were kept constant within the specified tolerance ranges during welding, that there were no irregularities in the main supply, and that there was no critical damage to the machine, which I think we'd all agree is the purpose. But it's what comes out of that data. All the relevant data, the set values as well as the output must be measured and plotted, and they require less than 50 centimeters. So that's their requirement for recording. Another requirement is an acoustic signal shall sound and the deviation shall be recorded if values stray beyond the tolerance ranges, which that sounds like a good thing, and I believe it is potentially a good thing as long as the tolerances are properly set. But again, you still need to go back to a baseline. The measurement data assigned to the weld seam shall be stored in such a way that it cannot be modified. Well, that makes sense too. That's perfectly fine. But as we get into this, you'll see that I'm not sure that's really the case. So here's some concerns that you should be aware of. I already touched on some of them. A lot of them are going to be somewhat redundant from what I brought up in GRI GM32, simply because they still haven't been addressed. And, I think it's important that we talk about them. So the elephant in the room, this is a big one, really. And, my staff gave me, I don't know, 20, 25 pictures of elephants in the room to use for this presentation. And I really chose this one because I felt like it really represents our industry. I had all those people pushing that, hey, this technology is going to get out there. It's a great technology. Well, I don't think they're seeing some of the things I'm sharing with you here. And I think, the elephants behind them, they're the ones that aren't seeing it. They're, believe it's the next best thing, but um, there's still some steps we need to take to get it to be in the next best thing. And some of us in the industry are cautiously optimistic about it. And that elephant in the room is baseline data. And I've mentioned it a couple times already, but here, if you're looking at baseline data for human blood work, you go to the doctor, you get a medical report. White blood cells, they give you a normal range. They show where your value is. Red blood cell count, normal range, show you where your value is. Platelets, show you your normal value. And in this case, it's outside the normal value. And, some of these can vary by age, by race, different things factor into it, but they have a good understanding of where the normal is and where you should be. And as you look at this next slide here, I'm just showing it over time, basically. You go in for one appointment, you're getting these results. You go in for another appointment, you're getting the next set of results. And they can track these, and your doctor sees something that's outside the normal, they're going to give you suggestions of what you should do to get back in the normal range. And, we just don't have this in the um geomembrane welding. Um, when you start looking at baseline data for data recorders, how do we know that any of these parameters are acceptable? And there's the combination of parameters: temperature, speed, and pressure. And we'll get into this graph a couple more times, at least one more time for sure, but it's a graph that went around showing, how this data can be used. But when I start looking at it, I want to know, first of all, how is that first line? How do we know that's good? And then how do we know any of these little squiggly things are good or bad? There's just no way to figure it out, and I'll explain why here. Um, I talked the last time about your baseline data for wedge welding. Well, here's that triangle again, your heat, speed, and pressure. But I identified, really a more accurate picture, I think, of what's happening than I had in the last webinar. And this green circle really indicates what Eddie would have had as your sweet spot, but I'm calling it more an optimum welding zone. And it's going to be where your trial weld passes and you have no geomembrane damage. Then what I identified as a danger zone, I highlighted in red. Stoplights here in the United States go from green to yellow to red. But I put red next because I think, this is a big problem here in the United States. We're in this danger zone, what I call the danger zone. You get a passing trial weld per the ASTM because it passed your peel and shear criteria, but geomembrane damage is occurring. So you're passing your trial welds, but you're compromising the long-term integrity of the liner. And then you have your failure zone, which I colored yellow because that one's obvious. We know pass or fail, and that's a pretty good. It's easy to identify, I guess I should say. Trial weld fails or the geomembrane fails. Either way, the trial weld fails. And, I talked a little bit about some of the problems, but if any of you want to go back to the previous webinar or look on your own, Dr. Ian Peggs, Dr. Carrie Rowe, you can see some of the issues that they've pointed out in the past, as well as others, simply only utilizing peel and shear, and how the molecular structure changes with overheating in the area adjacent to the weld and compromises the long term by increasing the likelihood of stress cracking. Basically, what we have here is we have a passing trial weld per the ASTM, So in the same circle, where does it fall? Maybe it's in the center, close to number one, center of the sweet spot, optimum welding zone. You got some flexibility. But if it falls on number two, any change in those variables, and you're going to be into the danger zone where you're now compromising the integrity of the geomembrane. And the same thing with number three, you're already there, which unfortunately a lot of our welding is done in that zone. Um, and number four, you'll be right at the failing trial seam. If you're outside beyond number four there, you got a failing trial seam, so you make some adjustments and you're back somewhere between one and four. We simply just don't have any baseline or reference of where we're at other than we have a passing trial weld. We don't know if we're compromising the liner integrity or not. And I looked for this baseline data, as I mentioned in the last webinar, for guidance on what temperatures, what speed should we really be running at. I think it really boils down to a coefficient of heat transfer, and that's beyond my pay grade, but somebody can come up with that, I'm sure, for each of the materials. So we looked all these guidance documents that are, big name documents in the industry, often referred to. There was nothing there. Then I went to the manufacturer's data, and they had suggestions on where to start their welding, but then it really became pretty obvious if you look at Demtech, they have their suggested starting temperatures, and then Leister has their suggested starting temperature, speed, and pressure. You look at the temperature, there was a difference of 60 degrees Celsius or 140 degrees Fahrenheit just on your starting temperature for HDPE. And that just seems like too great a difference to me. Um, if you're talking the same material, it just doesn't seem that you should have that much of a difference between your starting temperatures, everything else being equal. And then the other thing was that Demtech doesn't have any pressures, but I believe that's because of the way their machines are made. So the data recorder device setup is another key thing. We've seen it before here. Proper setup is required, and it really is dependent on the user. So it's important. This quote is out of the Leister manual. If the alarm is deactivated, the alarm values will not be monitored and the events will not be logged in the welding data file. So somebody can just disable that. You're not going to have any alarms. The operator isn't going to know if they're attentive to do anything. And they're not going to record the alarms in the data. It seems like that defeats the whole purpose of it. So there has to be proper setup if these devices are used. And I'll get into how they're set up here. Now, this is a graph that was in the Leister manual, and they talk about, your tolerances. The zone 4 here, if you can see my cursor, really is your lower limit and your upper limit, where it's going to alarm. Basically, it's not going to alarm between them. Same thing. This one is which one? This one is speed, actually, and then this is temperature here, the second one down, and then pressure. So as long as your parameters are staying within like 7 and 8 on the temperature, it's not going to alarm. But 7 and 8 and 4 and 11 and 12, all these parameters, the tolerances are defined by the user. So the user could actually put these to the maximum and minimum, and you could weld the whole project and you never have any alarms going off. And, that's why it has to be double checked by somebody because it will happen. I'm sure it's going to happen. If it hasn't already, it probably has. And here's the devices. You can see the comet here. If you go to the setting range, the alarm minimum temperature, it can be set 70 degrees to 485 degrees Celsius. Same amount for the alarm maximum temperature. So you could set the minimum at 70 and the maximum at 485, and it's going to rarely have any alarms unless you're really welding outside those parameters. I mean, that's just one of the things that you need to be aware of, that just because there's no alarms doesn't mean that they were staying close to where they needed to be. So then I looked at welding machine calibration. I know a couple people brought that up in the last webinar too, and we went through these documents on this page. I'm not going to identify them all, but there's 5 documents here, another 3 documents here, so that's 8 documents, all prominent documents that people look at. Even operator's manual for equipment, and nothing was mentioned about welding machine calibration. We only found 2 statements on the calibration of welding machines. One came from an Adderfill installation manual for their conductive material, but that one basically boils down to it's talking about the trial welds, and calibration should be done with the material facing down. The only one that actually talked a little bit about the welding machine itself was found on the Leicester site website. And it states that these principles include a closed control loop to maintain the welding temperature, a closed control loop to regulate the welding speed, and a calibrated pressure system with a load cell or measuring system to ensure a reproducible welding pressure. Whereas a lot of machines in the United States that are being used that don't have this load cell, and you can't produce a reproducible pressure. You can't guarantee it because you can't monitor it sufficiently. Then calibration of the data recorder. It says in ASTM D8468 that it's supposed to be calibrated, but has anybody seen calibration? I've never seen any calibration on them. And tensiometer load cells are always a submittal that they've been calibrated. They need to be calibrated in 6 months or a year typically. Um, so, it's something that probably should be in a submittal requirement. So next, I'll try and talk to you about the individual welding parameters a little bit, and we'll start with heat. How do we know what the temperature really is? There's lots of questions that come to mind really regarding the settings for each of the 3 parameters. Does the true welding temperature actually match the welding machine display? That's a big one. How do you verify that? It could say it's 800 degrees Fahrenheit, but is it really? Same thing with a data recorder. If it's saying 800 on the machine, is the data recorder saying 800 or is it saying something different? And then each one of these slides has those statements just as a reminder that, these were things in the guidance documents that we looked at earlier. Um, but yeah, for heat, if you look at the pipe welding, HDP pipe welding industry, they require that there be a pyrometer used to check the temperature because they said the thermometer on the heaters indicates the internal temperature and should be used as a reference only. So they require that. We don't require anything. Is 800 degrees Fahrenheit on our wedges really 800? How do we verify that? And does it change? Is 800 really 800 with a porcelain wedge, with a stainless steel wedge and a copper wedge? Do they all stay the same or not? You know, They're just questions I come up with when I can't sleep. Um, but individual welding parameters, the speed. Again, they're saying that we need to verify it, verify that the manufacturer has confirmed it, and then the practice doesn't cover those. But speed probably is really the least of my concerns if I'm in the field because I can measure it. I can time it out and measure it. But if you're doing that, then you got to take into consideration other things we're going to talk about, like the measuring device and that. But you can get a relatively good idea if the speed is changing. Um, the article, they had findings regarding speed on their site too, and they said that the installer needed more flexibility in their tolerance window because of increasing sheet temperatures as the day progressed. Well, site 2 was with a 40 mil, so that's a thinner material. I don't know anything else about the site, but that somewhat makes sense. But they just adjusted the tolerances based on additional trial seams, which I don't think is the best idea to do, given what we just discussed about not having a baseline. Um, Pressure. again, same graph from before, and you can see different anomalies there. One they said was a leak, one they didn't seem too worried about. And this article itself had some findings on the pressure. Um, what they had is that there were pressure variances observed on site one. Um, the pressure value during welding was significantly different than the set value. So the welding pressure was observed to be, in a quote, approximately 70 pounds foot or force per foot, less than the set pressure. So that just really raises a lot of flags to me. So I asked manufacturers about that, and I'll get into that in a moment here. But what they did, they just said therefore the seaming pressure tolerances set in the welding machine were adjusted to account for the set to welding seaming pressure change. That just doesn't make sense because where's the calibration on it? How do we know that any of it's right if you're just making adjustments because they don't match? To me, they should be matching or there's an issue. Um, so then pressure variances were noted to have occurred at T's, Siemens, anchor trenches, wrinkles. Low pressure was recorded at anchor trenches, Siemens, and wrinkles. High pressure is recorded at geomembrane T's. The geosynthetic installer and CQA personnel attributed the low pressures to technicians holding the welding machine by the handle, and the high pressures were um, attributed to welding machine passing over 3 layers of geomembrane. But those are just really, they're just making a random decision there. They're attributing it. I mean, they inspected it at least, but they're just saying that's the cause. How do we know that's the cause? And should there really be this much variance? Interestingly, there was no site to pressure variances. Um, so I ended up talking to different machine data recorders about this. My first statement, I said, I am curious to hear your take on the Geosynthetics magazine article. And the one manufacturer thought the article was misleading. He said the tolerances were set too narrow. If they had been opened up, the wrinkle wouldn't have shown up and we wouldn't even realize. Well, that doesn't give me a great deal of confidence and make me feel all warm and fuzzy about the project. I don't know how it does for the engineers, but I couldn't live with that if I was a certifying engineer. Um, maybe why I'm not, but anyway. Another statement I said, I am surprised that you never mentioned the pressure before. This was a follow-up statement, that it can be changed by the operator welding through a wrinkle. You never mentioned that before. They said, well, I never mentioned it because it's obvious. It's a factor that happens all the time with, whoops, welding machine. Ah, I lost my place. Where was I? Oh, there. Um, it happens all the time up until now you never seen it and it was never an issue. So it surprises me that it's a big deal for you. Well, that's part of the thing with the data recording is now we have something to tie into. Now you're seeing some of this stuff. I've seen people wrestle with wrinkles, and I know from experience that destructs I take on them had a higher failure rate. They should always get rid of the wrinkle if they can, but that's not always the case. But you'll have a higher failure rate. So I know there's a potential for an issue. I just never thought about it that seriously until you see the data. Um, and again, pressure, I said, manufacturer one said no one is claiming that a wrinkle is an anomaly. Well, if it shows up on the data, how do we know? How do we know what it is? That's kind of defeating the purpose if we're not saying it's a wrinkle. And even if you measure the distance and come up there, how do you know that that's the only thing wrong at that spot? Manufacturer two, the pressure can easily be impacted by 5 psi, which I think they used the wrong units there, but that's what they told me, by torquing on the machine for a wrinkle or other reason. So, that's eye-opening to me. I don't know about for the rest of you, but to me, that was pretty eye-opening that, okay, so what really does constitute something that deserves to be looked at in the field? How do you know? If everybody's just going to walk around and say, oh, it's a wrinkle, oh, it was a start point, oh, they welded through extra material, are we going to look at anything and get any value out of the data? Or just ignoring it too? I mean, either way is bad. There's got to be some guidance. And getting into guidance, data analysis. Data output is often dependent on the data being set up when it's set up. So, bad data in, not enough recording, you're not going to get the best picture. Seam correlation is critical. And is all the data available for review? The ASTM makes it sound like it should be, but when you look at this manual here, it says you can mark the data file as sample welding or faulty welding. And if necessary, you can mask the files designated as sample welding or faulty welding. So to do this, select hide test weld option and hide the failed weld at the top right. I mean, are we getting all the data or not? I mean, how do you know? And most of the time, as a CQA person, you're not getting the data firsthand. It's going through the installer and they're giving it to you. So are you really getting it? It's something you got to think about. Um, and another big one to me is location. I mean, I think I about gave the one manufacturer a heart attack because I said, "How do you find that exact location?" And he got pretty angry with me. But they're doing it with their machine, and it's saying it's 400 foot from the start of the seam or wherever it may be, but it's basing it off its start point. Okay, but their argument was that their machine's calibrated. What about my measuring wheel and blah blah blah? Well, good point. I agree with you. You're probably more accurate with that machine than we are with a wheel, but I still need to find that same point. So how do we do it? The GPS data isn't accurate enough to pinpoint it at this point on the machines. So you can use any of these different methods, the wheel, size of wheel, all these are going to vary. There's too many variables here, expansion, contraction, starting points, angle of the wheel, bridging. Um, I believe there needs to be an examination window of some set amount distance. And Leister actually says, I didn't see it in their literature, but in talking with Eddie Weiser, he says it's 2% of the seam length. So, that's good, except that your examination window increases as distance increases. And is that 2% accurate enough? I really don't know that. And you can see here, it's just a quick table of, the increase. 100 foot's going to be, you got to look 2 feet in each direction. 500 foot's going to be 10 foot in each direction. But then that plays into your inspection and decision making. Is there something obvious within the examination window? Okay, if there is that really the anomaly? And if it's there, is that really the start and end? Sometimes you have burnouts. There's issues before the burnout that started and the liner got, excuse me, bad. Um, and if there's nothing visible within the examination window, what do you do? If you do nothing and you're going to repair it, then you're looking, at these different size repairs I put in here just to figure, at 500 foot, you're looking at a 20-foot repair on each side, and then that's going to be 42 feet of extrusion weld if it's 1 foot long. So you got the options of leave it, do nothing. Do you destructively sample it, cut it out for evaluation, repair the footprint of the examination? And then who bears liability for the decision based on this data? In the article said that there were trial welds that often showed tolerances could be exceeded up to 3 times the project value before seam strengths were affected. And they believed it was a factor of safety, diminished the need for absolute tolerances on the welding parameters. I totally disagree with that. Um, they also said the risk to extended installation time and cost from destructive testing were reduced because the data and quality-based geomembrane field seaming framework resulted in no destructive sampling for Site 1 and reduced sampling for Site 2. But again, I go back, where did we begin? Is it on point 1 here in the center of the sweet spot, or did we begin in 3? And maybe we shouldn't be making those decisions like that. What happens to the data? Is it archived, submitted to the regulatory agency with a report? That's a big question that needs to be answered, maybe on a state-by-state basis or project by project, but I do think it's something for regulatory agencies to consider. So how can we use this data successfully? The biggest thing to me is we got to use it with extreme caution. There's so many unknowns out there. I think making any decisions on it really is a risky proposition. I think that we need to, look at the data, collect data. The data can potentially help us in the future to make decisions, but right now it's without that baseline, it's hard to do. So I think you need to really go back to your standard CQA, monitor all your trial seams, monitor and walk all seams, and the CQA team certifying engineer really need increased responsibilities rather than becoming non-existent as the U.S. patent says. You really need to have, or suggests anyway, that the requirements of the ASTM be verified. And then CQA personnel really need to monitor the machine setup of the data recorders and verify any parameters. Um, if the data is being used for evaluation, timeliness is critical. And then data must not be allowed to be hidden. And then I say restrain from altering, protocols. I don't think that we should really be making decisions that we can't take, or we should minimize destructs simply based on this data. Not until we have baseline data saying that, okay, this is where you can weld and you're not damaging the geomembrane. Once we have that, I think it might be a whole different ballgame, but we're not there right now. I do think that we should add voltage in as a required parameter. You can see here, this come from Leicester. But if there's less than a 5-second delay in the power or interruption, the device is going to continue running and it's going to keep going. It's going to stay with the same settings. Those spots really need to be looked at and known. You need to know. It's more obvious if the device just shuts down, like they say, but if there's something happened to the power during welding, those spots really need to be looked at. And, I think having operators mark each anomaly in the article, one of the sites did, I forget if it was one or two, but that's the only way I think that they can be used really good is if an operator is attentive, they see that it goes outside the set window. You'd have to have a good window that was agreed upon by everybody, and they mark anything they find at the time. But again, you need somebody there. How many times have you seen people out there, the wedge running on its own? We see it all the time. Nobody's in this photo. Um, and as I said, that was done in Article 2, on Site 2 in the article. We just still don't know anything about the initial weld or the tolerances. So, at this point, at least, if everybody agrees on a window for the tolerances, at least you could verify that, but that doesn't necessarily mean you're still not damaging the geomembrane. And this is a short video that runs for like 20 seconds, but it was probably a 30 seconds or a minute before I was able to get my video going. So this person, they're letting the welding machine go and it's just running down the seam. And this is again only 20 seconds, but I'm saying it was more like a minute before the person got back. So the data is not going to have anything. I mean, people are going to end up thinking the machine's going to tell them all the problems, and you're potentially going to have more of that than you are less of it. Other potentially useful applications, I believe you can keep the installers honest. You can ensure that the welding parameters were not changed, whether they mean anything. I've already beat that one to death, but at least you can make sure that they weren't changed. And this is really valuable to me, in particular when end coupons are taken, because every job we go on and we audit, you'll see where the installer changes the settings on their machine as soon as they're away from the end and right before they get back 6 to 10 feet out, they'll change it back, and the CQA people don't realize it. The other people don't realize it on site. So it's one way of keeping them honest. Um, but again, what variances are acceptable once you start doing that? And I believe the patent actually touches on this too, but you can help keep, identify issues with materials. We've seen where material was bad and installers were failing, but it was not the installer's fault, it was the material. Problems with welding machines, as the DVS alludes to, and then, personnel. We've seen on sites where there's been a welder operator. He's picked up two or three different extrusion guns, two or three different fusion machines. Every one of his initial trial welds has failed. Why is that guy still allowed to do it? Just because he can get a passing trial weld, it doesn't give you much confidence that they can do any actual welding. So that's really my end of this webinar. As far as the content goes, I apologize for the rush at the end. I apologize for the gaffe at the beginning. I thought I had it up on the screen and was running smooth this time, but we'll get there. 2025 will be a better year for this. I'll get it right. So up next is findings from the field, earthwork and geosynthetics, the things that we've seen during our audits on our projects in 2024, good and bad. The bad, maybe what we can do to change some of that. That again is going to be Thursday, January 17th, 2025 at 12:30 p.m. Eastern. And I look forward to you joining me then. And now I'll try and take your questions and answers. I got to figure out exactly how to get back to the little hand thing here, but if anybody's getting ready to leave or jumping off before the questions and answers, have a Merry Christmas and I'll see you in 2025. Um, and then one question I have to look into. I'm not sure exactly what you're asking, though. There appears to be a UFGS section, and that's the United Facilities Guide Specifications, Division 31, Earthwork, Section 3105, 19.13, geotextiles for earthwork dated 2 of 2021. Does this document answer any of these questions? And I will look into that. I'm not familiar with that document, so I want to thank you for pointing that out to me, and I will look into that. That's the only question that I have that anybody has. We got another minute or so. Does anybody have any more questions? Um, all right. Well, thank you for joining me, and I look forward to seeing you in 2025. Stay safe and have a Merry Christmas.